Honorable Principal, Nirmala College, Ranchi, and patron of the 5 days online skill development program, Dr. Sister Jyoti. Vice Principal, Sister Shobha. Our esteemed mentor for the day, Dr. Kirti Avishek from Department of Civil and Environmental Engineering, BIT Mestra, Ranchi. Our CP coordinator and head of the department, Dr. Devjani Roy. Organizing committee members, faculty members of various departments, and dear participants. Wish you all a blessed and a very good afternoon. On behalf of the entire organizing committee, I extend my warm welcome to each one of you on day 2, session 4 of the 5 days online skill development program on basics of GIS, RS, GPS, organized by CP Committee and Department of Geography, Nirmala College, Ranchi, in collaboration with BIT Mestra, Ranchi, and sponsored under the UGC CP scheme. With the permission and blessings of the chair, I would like to begin the session.
Okay, please go ahead.
Thank you, sister. In recent years, Earth's surface has undergone various land cover and land use changes. Detecting these changes in specific classes, such as farmlands, forest, urban areas, and water, has been proven to be important in various studies. However, these changes are slow and go unnoticed unless they occur at large extents. To detect, understand, and prevent these changes, analysis and interpretation of data through spatial techniques have been highly beneficial. For instance, surface water, a vital resource for household, industrial, and agricultural consumption, which is also a very good indicator of land cover changes, is affected by environment, climatic, and anthropogenic activities. Remote sensing technology in combination with GIS can be useful in monitoring current conditions and spatial as well as temporal changes of rivers, reservoirs, lakes, etc. RS has not only become a backbone of hydrogeological reconnaissance in areas with insufficient field data and detailed map coverage, but has also become a relatively low-cost alternative for feature detection and understanding hydrogeological systems in well-mapped regions. Pertaining to this very fact is the topic of the current session, spectral bands and indices in remote sensing. Our illustrious resource person, Dr. Avishek, will walk us through the techniques of classification of vegetation on the basis of their health and chlorophyll content. This will be done on RS platform. The primary focus of the session will be on forest resource assessment and management, for which he will be using urban and water indices. Over to you, sir.
Thank you, Dr. Chakravarti. And faculties and family of Nirmala College. Thank you once again to bear with me. And I hope after lunch, the students are not feeling a lot of sleepiness. So we hope we again have a interactive session like we had in the first half. And I will be continuing as my first session was again started with a recap. So again, we will be having a small recap and then I move into the next session. Now, I assume that the first session today was very exhaustive and it took almost 1.5 hours to complete. So this specific presentation is only of 12 slides. I've tried to limit myself and my main focus will be to understand that you catch the thing even bit by bit and it is not very exhaustive for all of you also. So as a recap, since this is the end of second day, I would ask a few questions which I expect the students can answer on a YouTube platform, chat platform. So before I start my presentation, so that in case there is some repetition of information or some knowledge gaps which you feel needs to be clarified, I can do that. And as per the request made again from the feedback that you need some bilingual language support also, so I will be going for both English language as well as Hindi language. So hopefully you'll be able to understand in a much better way. So since yesterday we are talking about remote sensing, we are talking about GIS, and we have this is the fourth session that we are having now. So let me just ask a very basic, simple question, and what this is: what do you understand by remote sensing? हम लोग तो बहुत कुछ आगे की बात कर रहे हैं, but क्या आपको definition समझ में आया है? What is remote sensing? Can I ask the students who have already registered or are already present in the chat box, in the chat room, to answer this question? You may be wrong, but आप लिख सकते हो, आपको जो समझ में आ रहा है आप लिख सकते हो, ताकि मैं फिर से उसको समझा दूंगा उसको. I see few names like Mahima, Ritika, Antara, Anshu, Monica, Aarti, Ashu, Gargi, Abhinav, Shweta. So maybe if somebody can give me an answer to, like, what do you mean by remote sensing? It is an advancement of technology which makes the technology more easy to handle. Okay, it's a technology, but how do you define? Suppose you are at home and your parents ask you, can you tell me what is remote sensing? Okay, fine. Rupa is giving an application-based answer that you can get data from areas which are inaccessible. Fine, but that's not a definition. To get idea of places remotely, quite close. Abhinav is quite close to the answer. It is a technology of acquiring information about Earth's surface without actually being in contact. Okay, Beauty Tiwari, your answer was perfect. When we go for technical definition of remote sensing, it is basically the acquisition of information in a manner without touching an object. So we try to achieve that knowledge about anything without being without getting in touch with it. So can you give me one example of remote sensing occurring in your life? My second question. Can you give any instance or any example of anything where you are acquiring information or changing information without being in touch with it? Yeah, I'm getting good answers from Nidhi, Sam Kujur. Yes, Sumitra, very good. By eyes. Eyes are already working in an optical remote sensing method. So whatever we are doing right now is also part of remote sensing. Because whenever we see somebody, we try to, our eyes are like an optical sensors, and the brains are working in a manner that we are acquiring information about it. So that's a good example. Very good. So basically, if I answer in Hindi, कि किसी भी चीज को बिना छुए हुए अगर उसका इंफॉर्मेशन या नॉलेज हमें मिल जाता है, so that is remote sensing. ठीक है, without acquiring or without touching anything, if we are able to gather the information about any feature, that's called remote sensing. Eyes is one example. Second example is your remote control. Since ages we have been using remote control, so we are basically changing the information of a television without actually touching the television. So you have remote controls over there. So again, two very good examples. Wonderful. Yes, that's fine. Wonderful. How do you define GIS? It has not been dealt as of now, but I think tomorrow you have a session on GIS, Geographic Information System. GIS stands for Geographic Information System. So in a very layman language, I will just elaborate. Like GIS is किसी भी geographic feature का information database. So it's an information database of any specific feature. तो फॉर एग्जाम्पल फॉरेस्ट, तो फॉरेस्ट एक फीचर हो गया, बट फीचर का क्या उस जोग्राफिक फीचर में जो फॉरेस्ट आ गया, बट उसका क्या इंफॉर्मेशन डेटाबेस है. सो उसका इंफॉर्मेशन डेटाबेस इज एन एक्सेल शीट. इट्स लाइक एन एक्सेल शीट और एन एट्रीब्यूट टेबल. तो उसमें हम लोग ऐड करते हैं कि ओके इसका फॉरेस्ट टाइप था, साल फॉरेस्ट है, डेसिडुअस फॉरेस्ट है, कैरेक्टरिस्टिक्स क्या है. So all those features that we are adding to it results in a creation of an information. So that's called an information database. Okay. So remote sensing is basically directly working on tools using AirDAS Imagine and ArcView, ArcGIS are tools where we are using the features and its creation of database. Okay. So it's like something like an Excel sheet where we feed data, और वो जो डेटा होता है वो ऑटोमेटिकली स्पेसिफिकली दैट स्पेसिफिक फीचर के साथ अटैच्ड होता है. सो आई होप दिस इज अंडरस्टूड. ठीक है, चलो ठीक है. नेक्स्ट इज when we are talking about photo interpretation, what are the different tools or techniques for identifying? Do you remember them? What are the interpretation keys? Can you answer what is NIA? I think there's a question from Aditya Anand. What is NOAA? NOAA is National Oceanic something. I don't recall it very well, but it's on National Oceanic and Atmospheric Studies के ऊपर कुछ है full form इसका. It's also a satellite based something. My question is, I'm repeating again. My question is, how do you interpret a satellite image? So what are the interpretation keys? Interpretation keys. Basically, tone, texture, shape, size, association. Yes, Vasundhara, you are writing it correctly. So tone, texture, shape, size, association are examples of visual interpretation keys. So visually, when you are trying to study a satellite image, so use these specific tools to identify a feature. Tone, texture, shape, size, and association. Okay. So again, I'm repeating again. Can anyone tell me what is the tone of agriculture? I'm repeating again. What is the tone of agriculture? Can I get some answers for this? What is the tone of agriculture? Pink. Perfectly fine. Okay. Shilpi is correct. Mahima is correct. Shweta is correct. Swati, you are correct. Tripti, you are correct. How do you differentiate? My next question. How do you differentiate between dense forest and agriculture based on tone or texture? How will you differentiate agriculture with forest? Agriculture, as you said, it will be in a very lighter tone. Yes, I'm getting the answers now. Pfizer, dense forest, and dark red. Correct. Perfectly fine. Dark red and pink. Dense forests are maroon in color. Okay. Smooth. Very good. Shilpi is also correct. They are rough and they are smooth. Fine. So basically, if you see all these things, you will understand that agriculture is in the lighter shades of red and pink with a smooth texture, whereas forest is dark maroon in color with a rough texture. So a very good understanding that you have captured so well. How do you differentiate between cloud and snow? My next question, how do you differentiate between cloud and snow? And that question that you had asked, NOAA, it is National Oceanic and Atmospheric Administration. Last A is for administration. Clouds are irregular and smooth. Fine. Snow has no shadow. Cloud has shadow. Perfectly fine. Very good. So it's a good indication that your students are actually grasping what is being taught. So our motive of K plus one, which I was dealing with as knowledge plus one level, so that I think you are trying to attain it. So that's a very good, very good way. Cloud has a different pattern and it forms shadows wherever snow is regular, whereas snow is perfectly fine. Yes, clouds are in small patches. Very good, Devyani. Yes, Aditya, perfect. Good. Fine. So basically, what I perceive is you have understood till now whatever has been dealt with. You have understood the concepts. So then we can move to the next stage. So now I'm going to start my presentation on the next topic. I think the presentation is visible to all.
Yes, sir. Absolutely.
Thank you. So students, we are dealing with spectral bands and indices. And keeping spectral bands in mind, I have one small question which we dealt in the last session. Like, suppose, what do you mean by spectral resolution? Can anyone write what do you mean by spectral resolution? Spectral resolution. Can anyone recall what is spectral resolution? Can I have any answer or should I proceed? It depends on the visibility of band, visibility, ability of a sensor to define wavelength. Okay, good. Yes, it's basically the ability of a sensor to identify or detect the different wavelengths. That is the spectral resolution. So if it is a panchromatic image, panchromatic means one single band. One band is panchromatic. It's a black and white image. Whereas multispectral is a colored image. You have three bands. Okay. So it's a colored image. It depends on the wavelength. Fine. Good. Ability of a sensor to define wavelength. Fine. Spatial resolution of a resolution. Yes. Good. So now we go to the next topic, which is spectral bands and indices in remote sensing. And let us just start with again a recap. We were dealing with IRS, so Indian Remote Sensing Satellite, IRS, list 3. List is the name of a sensor. So I'm dealing again, LISS is the sensor. IRS is the satellite, Indian Remote Sensing Satellite, and LISS stands for sensor. LISS का full form होता है Linear Imaging Self Scanner. The full form of LISS is Linear Imaging Self Scanner. And 3 or 2 or 1 denotes the series. कि कितने series में वो develop किया है. Okay. Now, IRS is one specific satellite which has a sensor, list 3. List 3 sensor का जो specification है, that is mentioned in this specific slide. तो अगर हम पूछते हैं कि इसके spectral bands कितने हैं, so what can you say? The spectral bands are, can you count the number of spectral bands? If you read this specific slide, the spectral bands are there. There are 4 spectral bands. Okay, there are 4 spectral bands for list 3. The wavelengths are given over here. There are 4 spectral bands for list 3, and each band has a specific wavelength. That wavelength is also provided over here. Okay, so similar to this, you have wavelengths for several other satellite sensors. So जितने भी sensors होंगे, उन सभी sensors का wavelength mentioned रहेगा उनके साथ. Okay, so you can explore, like in the day 1 in the inaugural session, when we were dealing with the number of satellites and their names, if you start searching their sensors, so you will get number of sensors and number of sensors के number of wavelengths. अब आपको as a user कौन सा wavelength पे काम करना है, कौन सा wavelength useful रहेगा, उसको आपको decide करना पड़ेगा. ठीक है? But that you will learn in due course of time when you go for higher education, maybe a master's in remote sensing or an MTech in remote sensing, MSc or MTech in remote sensing, you will be able to understand those things. Okay. So coming to the main topic, which is indices. Pronunciation at times is indices, at times I speak indices. So I might be right, I might be wrong, I'm not very sure of it. So आप indices भी बोल सकते हो, आप indices भी बोल सकते हो. Now, the purpose is आप indices के बहुत simple form में अगर हम बात करेंगे तो it is an index. So index value calculate करना. So index value calculate करना मतलब कि it is a some kind of a value to range between something. ठीक है? So हम लोग करते हैं indices या हम लोग किसी भी सैटेलाइट इमेज में हम लोग ये परफॉर्म क्यों करने की कोशिश करते हैं. विजुअल इंटरप्रिटेशन तुमको समझ में आ गया कि हम लोग क्यों कर रहे हैं. विजुअल इंटरप्रिटेशन इसलिए करते हैं ताकि वी आइडेंटिफाई द नंबर ऑफ फीचर्स, कौन से फीचर किस टोन में है, क्या चेंजेस आ रहा है. बट जब हम लोग बिल्कुल नैरो डाउन कर रहे हैं कि मेरा स्पेसिफिक फील्ड ऑफ एरिया है वाटर, या मेरा स्पेसिफिक फील्ड ऑफ एरिया इंटरेस्ट है फॉरेस्ट या अर्बन एरिया, तो डिपेंडिंग ऑन माय फील्ड ऑफ इंटरेस्ट आई कैन नैरो इट डाउन फर्दर टू एक्सट्रैक्ट मोर इंफॉर्मेशन. ठीक है? So basically, indices is an example of a spectral enhancement technique. एनहांसमेंट मतलब किसी एक फीचर को बहुत अच्छे से उभर कर दिखना, दैट्स कॉल्ड स्पेक्ट्रल एनहांसमेंट टेक्निक. फाइन. So for example, when you're gelling your hair, so what happens? You're trying to make your hair more attractive compared to everything else, है ना? Like so likewise, it's a kind of enhancement technique. So you're trying to drive the focus key, look at the specific features. Okay. So similarly, when you are going for satellite data interpretations, at times, since these satellite data are huge in sizes, so many a time कोई दो फीचर का मिक्सिंग अप हो सकता है अगर आप ठीक से क्लैरिफाई नहीं कर पाए, ठीक से आइडेंटिफाई नहीं कर पाए. तो जैसे कि वेजिटेशन के बगल में फॉरेस्ट है, तो वहां पे थोड़ा मिक्सिंग हो जाएगा. मे बी स्मॉल वाटर बॉडी है अर्बन एरिया के बीच में, तो वो थोड़ा सा मिक्सिंग हो सकता है. तो हाउ टू डिफरेंशिएट then in that those cases indices are very particular. So आपको कोई एक स्पेसिफिक फीचर को और फर्दर एनहांस करने के लिए हम लोग इंडिसेस का यूज करते हैं. एंड इंडिसेस आर बेसिकली दे इम्प्रूव द इमेज इंटरप्रिटेशन. किसी भी इमेज को और अच्छे से इंटरप्रेट करने के लिए हम लोग इंडिसेस यूज कर सकते हैं. इट इज ऑल्सो यूज फॉर फीचर एक्सट्रैक्शन. मतलब अगर हमें सिर्फ फॉरेस्ट चाहिए तो हम लोग इंडिसेस यूज करके सिर्फ फॉरेस्ट के फीचर्स को एक्सट्रैक्ट कर सकते हैं. Then how the features are changing, so वो trend analysis दोबारा हम लोग कर सकते हैं एक specific feature को लेकर के. ठीक है. So one thing I'm repeating again, indices or indices is basically used for enhancing a specific feature. It's an enhancement technique which will result in better and improved image interpretation followed by extraction. अगर हमें कोई specific water body को बिल्कुल extract करना है with the boundaries, so we will be able to extract that specific water boundaries. ठीक है. And ultimate objective is कोई भी चीज हम लोग का है उसका error reduction. So it will be a reduction of error. But what is indices? Indices is basically a ratio. It is unitless. हम लोग जब wavelength की बात करते हैं तो वो मीटर में आता है. ठीक है. लेकिन जब हम लोग यहाँ पे इंडिसेस की बात करते हैं तो वी आर बेसिकली डिवाइडिंग टू डिफरेंट फैक्टर्स. तो दो फैक्टर्स को जो एक ही यूनिट पे आते हैं उनको जब हम लोग डिवाइड करते हैं इट बिकम्स अ यूनिटलेस फैक्टर. सो इट इज अ यूनिटलेस फैक्टर एंड अ रेशियो ऑफ टू बैंड्स. व्हेन आई से टू बैंड्स मतलब दो वेवलेंथ का रेशियो है ये. ठीक है. तो किसी भी दो वेवलेंथ के रेशियो को हम लोग इंडाइसेस बोलते हैं. ठीक है. फॉर एग्जाम्पल एक वेवलेंथ हो गया नियर इंफ्रारेड, एक वेवलेंथ हो गया रेड. तो ये दो डिफरेंट वेवलेंथ है, लेकिन दोनों का जब हम लोग रेशियो कैलकुलेट करते हैं तो उसको हम लोग बोलते हैं इंडाइसेस. इन अ वेरी सिंपल एंड लेमन लैंग्वेज, अ रेशियो ऑफ टू वेवलेंथ्स और टू बैंड्स इज कॉल्ड अ इंडाइसेस. कैसे कैलकुलेट करते हैं वो हम लोग आगे पढ़ेंगे. ठीक है. इस प्रेजेंटेशन में हम लोगों ने सिर्फ 3 डिफरेंट इंडाइसेस पे फोकस किया है, NDVI, NDWI एंड SAVI. NDVI stands for Normalized Differential Vegetation Index, Normalized Differential Water Index, Soil Adjusted Vegetation Index. ठीक है. बट इस तरीके के बहुत सारे रेशियोज हैं, बहुत सारे रेशियोज. हम सबसे सिंपल रेशियोज हैं और जो सबसे पुराने रेशियोज हैं सिर्फ उन पे वर्क कर रहे हैं यहाँ पे. बट अगर जब भी when you're exposed to a software you will see their number of indices. And the best part is you don't have to go for any specific calculations over here. Initially we used to go for mathematical calculations to identify these indices, but now these are already inbuilt in the software. So just you give the input file, output file, save it, and then the आपका ये run करके the output comes out. ठीक है. So it's a very easy tool. मतलब अगर तुम सॉफ्टवेयर में एक्सपोज करोगे तो it will be hardly within 10 minutes you will get an output of an NDVI. So बहुत fast retrieval हो गया इन सब informations का. Suppose you are suppose in ADAS Imagine. ADAS Imagine is one software which we are using for identifying the indices or running indices. तो उसमें इनपुट फाइल में एक रॉ इमेज ले लेंगे, आउटपुट फाइल में जिस भी फाइल का नाम हम लोग को लेना है वो ले लेंगे, प्लस हम लोग उसमें NDVI सेलेक्ट कर लेंगे ऑप्शन. तो जैसे एनडीवीआई ऑप्शन सेलेक्ट करेंगे तो ऑटोमेटिकली उसका फॉर्मूला फेड है। तो फॉर्मूलास क्या है वो हम लोग बताएंगे अभी नेक्स्ट स्लाइड में, बट ऑटोमेटिकली फॉर्मूला फेड है, यू क्लिक क्लिक क्लिक, result is out and the output file can be seen. Okay, what happens, but behind it what happens, what are the ratios, इन bands को हम लोग ratio कर रहे हैं वो हम लोग deal करेंगे, ठीक है। So repeating again, indices is a enhancement technique। किसी एक फीचर को हम लोग जब इलेबोरेट करके अच्छे से समझ चाहते हैं उसके लिए है, किसी भी फोटो इंटरप्रिटेशन को फर्दर इंप्रूव करने के लिए है, एक्सट्रैक्शन ऑफ स्पेसिफिक फीचर्स के लिए है, एंड ओवरऑल ऑब्जेक्टिव इज इट्स अ रेशियो एंड यूनिटलेस थिंग। So always remember, it's a ratio of two bands. Okay, any two spectral bands पर ये ratio होता है। Spectral bands बोले तो it is a ratio of either NIR band or an R band or maybe a S2IR band. So those are depending on each feature. So what is the logic? I will be explaining you in the later slides. I hope it's fine when I'm going in both bilingual methods. सबको समझ में आ रहा है ना ठीक से? So before starting this for this whole study of NDVI, I've also shared one link which you can also see anytime. It is available on YouTube, and it's a very good small link on showing on how NDVI works, Normalized Differential Vegetation Index. So इसको आप लोग explore कर सकते हो and see whatever I am telling you. It's not that something which is limited to in books. Yeah, it is something limited to my knowledge, yeah, to the library. But whatever is dealt from the internet sources. So no one can complain कि अरे हमको कहाँ से मिलेगा information. Everything is available on the Google. ठीक है, Google में, YouTube में you can find so many options. हाँ, आपको keywords पता होने चाहिए कि आपको क्या ढूंढना है. So we are here to assist you with the keywords, so that then you should be able to explore further. In 5 days, you cannot expect to learn everything about remote sensing, but at least you should have an idea of what are the components of remote sensing and how do we move forward. Okay? So NDVI is Normalized Differential Vegetation Index. It is an index which is used to measure the plant health. It is how it is done. The equation is NIR minus R by NIR plus R. That means we are dealing with near infrared wavelengths. Okay, so we are basically subtracting the near infrared wavelengths with the red wavelength. Now, why this is happening? It is basically a division of two. Like मैंने बोला था, it's a division of two bands. So the division of two bands is through near infrared and red bands. Okay, so two bands that are being used for NDVI is NIR and R. अब NIR क्यों और R क्यों, दूसरा क्यों नहीं, ये क्वेश्चन आ सकता है ना। When I am saying NIR and R, NIR क्यों, RE क्यों, बाकी बैंड्स में क्यों नहीं? So to answer that, NIR is a band which gives you the maximum information about vegetation. Perfectly fine, ये हम लोगों ने पढ़ा है last class में. NIR is a band which gives you maximum information about vegetation in, right, last class में पढ़ा था हम लोगों ने. So the maximum information minus R band. R is the red band which gives you the minimum information. Okay, so वो दो बैंड हम लोगों को ऐसे देखने पड़ते हैं जो मैक्सिमम और मिनिमम इंफॉर्मेशन, so that जो रेशियो आता है वो हमें मैक्सिमम आउटपुट की तरह आ जाए. So NIR minus R divided by NIR plus R. So thank you so much, Arunima. If you're able to grasp it, thank you so much. Okay, so NIR minus R and NIR plus R. The difference is NIR band gives you the maximum information about a specific feature, मतलब vegetation का maximum information आ रहा है NIR band में, और minimum information आता है R band में. तो हम लोग मैक्सिमम से मिनिमम को का माइनस करते हैं और फिर ऐड करके उसका रेशियो करते हैं। तो जो आउटपुट आएगा तो उसमें सारा जो वेजिटेशन है वो पूरा हाईलाइट हो जाता है। दैट्स द रेशियो, दैट्स द प्लस पॉइंट। तो एनडीवीआई का आउटपुट फाइल में बाकी सब फीचर दब जाते हैं और सिर्फ वेजिटेशन पैटर्न एक्सट्रैक्ट होकर बाहर आते हैं। So you will be able to identify every patch where you have some kind of vegetation. Okay, and always remember it's the ratio of maximum information by minimum information. ठीक है, कोई भी vegetation indices, water indices, soil indices हम लोग कुछ भी ले, always it will be a ratio of maximum information by minimum information. ठीक है, और सभी का रेंज -1 से 1 के बीच में होगा। जो वैल्यूज आएंगे हमेशा -1 से 1 के बीच में होगा। NIR is near infrared. Near infrared. Abhinav, NIR stands for near infrared band. ठीक है, ओके। सो मैक्सिमम इंफॉर्मेशन वेजिटेशन का NIR बैंड में आया, माइनस बाई द मिनिमम इंफॉर्मेशन। The ratio will be giving you a range between -1 to +1. So जो भी फीचर है उसका रेंज इसी में फैक्टर्स में आने वाले हैं। So chlorophyll is again a very good indicator. It strongly absorb visible light and the cellular structure of leaves strongly reflect the NIR light. So the reflection potentials is maximum in NIR. इसलिए हम लोग NIR बैंड को यूज करते हैं। So as I said, NIR is a ratio and the values for any kind of indices will range between -1 and +1. Values which are close to +1 indicates very healthy vegetation or dense forest. Okay, +1 to -1. So +1 के values indicate very healthy vegetation. -1 indicates no vegetation. Ideally, जो भी vegetation का range होगा वो 0.3 से 0.1 और 0.3 से 1 के बीच में होगा. I repeat again, the range of vegetation will vary between 0.3 to 1. Why so? Because dense vegetation से shallow forest से लेकर agriculture pattern सब कुछ vary करता है, and hence the range will also vary a lot. Fine. So it is 0.3 to 1. So 0.3 will indicate grasslands, 0.4 may be shrubs, 0.5 से बढ़ते चले जाएंगे तो forest का different stages को indicate कर सकते हैं. So based on all these things, 1 is means the dense forest. So you can easily identify such things. Okay, so all the way from shrubs, shallow forest to dense forest, ये range vary करेगा. I hope this is okay. I am repeating again. एक बार आप NDVI समझ लिए, बाकी सब ऑटोमेटिकली समझ में आ जाएगा. NDVI का मैक्सिमम any indices का जो मैक्सिमम आउटपुट है, that's based upon a ratio of bands. Ratio of band is we need to have 2 bands to create a ratio. It is unitless and the values will range from -1 to +1. Higher the value, healthier the vegetation. Lesser the value, lesser vegetation or no vegetation. Okay. So NDVI के जो range आएगा उसमें तो पूरे satellite image पे run करेगा. तो वैल्यूज जो 0.3 से 1 के बीच में होगा वो जनरली वेजिटेशन को डिनोट करता है. सो ऑलवेज रिमेंबर दीज थिंग्स. Now, Priyanshi, your question is to distinguish between healthy and unhealthy vegetation, which light can be used? It is always one single light. We are not changing the light source, right? Sun is the source of energy. So वो source of energy और radiations को हम लोग change नहीं कर सकते, right? So there is always one single. हम लोग वही red band, वही visible band, वही RGB, वही NIR use करते हैं for any kind of study. बट वेजिटेशन में जो डिफरेंस होगा वो ऑटोमेटिकली उन सेंसर्स पे डिफेक्ट चेंजेस आएगा. तो लाइट विल बी सेम, ये सोर्स ऑफ एनर्जी विल बी सेम. वी आर नॉट गोइंग टू डू एनीथिंग विद द सोर्स ऑफ एनर्जी. ओके. It is there in the PPT. Arunima, the link has been shared in the PPT. So maybe after the session, you can request the host so they can share the PPT with you. So you can obviously take it. Okay. Okay. Now this is a very simple example which I have taken from a specific research site. Research gate से हम लोगों ने लिया है, उसका source यहाँ पे mentioned है. So Landsat 8, February 2018. And Landsat 7, February 2002. इन दोनों सैटेलाइट डेटा का वेजिटेशन का हम लोगों ने इंडाइसेस निकाला. तो जो आउटपुट फाइल है वो आपके राइट साइड ऑफ द स्क्रीन में दिख रहा होगा. ठीक है. सो फॉल्स कलर कॉम्पोजिट इमेज विच इज अ मल्टी स्पेक्ट्रल इमेज, क्योंकि 3 या 4 बैंड्स यूज होते हैं, वो शोड है कलर्ड में. एंड एज आई ऑलवेज डिस्कस्ड, वन सिंगल बैंड मतलब जब रेशियो हुआ तो it got converted to one band. It's a ratio of 2, है ना. तो रेशियो जैसे होता है, so it converts to 1 and thus it becomes black and white. So this is the output file. अब यहाँ पे जहाँ पे आप रेड है वहां पे आप देखो वो व्हाइट पैचेस में दिख रहा है. ठीक है, व्हाइट पैचेस में. Now one thing you have to understand is it can be reverse also, depending on how you have arranged everything in your basic software. It's not necessary कि जो white patches है वही forest हो या जो black patches है वही forest हो. You can play with the colors now. NDVI में output file दिखा दिया तो कोई ना कोई एक opposite end में रहेगा shades. If white is forest, so non-white is or black is your non-forest. ठीक है. So always don't get confused कि सर हमको तो लग रहा है vegetation black में दिख रहा है. तो हो सकता है वेजिटेशन ब्लैक में भी आए, हो सकता है वेजिटेशन व्हाइट में भी आए. लेकिन अगर वेजिटेशन ब्लैक में है तो नॉन वेजिटेशन व्हाइट में होगा. अगर वेजिटेशन व्हाइट में है तो नॉन वेजिटेशन ब्लैक में होगा. बिल्कुल ऑपोजिट. ठीक है. स्पेक्ट्रल बैंड इज सिमिलर टू योर वेवलेंथ. स्पेक्ट्रल बैंड मतलब वी सेड रेड बैंड. तो रेड बैंड का जो वेवलेंथ होता है वो 0.6 से 0.7 होता है. ठीक है. So that is a spectral band. Spectral band is similar to a wavelength. So one band, one wavelength. Okay. NIR is 0.7 to 1.3. So that is the wavelength, and that's called one spectral band. Okay. So this is the just a very simple output of an NDVI image, a colored image getting converted to a black and white image. और जब आप इस स्पेसिफिक ब्लैक एंड व्हाइट इमेज को जूम करके देखोगे तो यू विल बी एबल टू अंडरस्टैंड कि कहाँ कहाँ फॉरेस्ट पैचेस या वेजिटेशन पैटर्न एकदम क्लियरली डिफरेंशिएट हो जाएगा. लुक एट दिस. दिस इज द आउटपुट फाइल. ठीक है. लुक एट दिस आउटपुट फाइल. अब लास्ट इमेज में हम लोगों ने वेजिटेशन को व्हाइट में देखा था. यहाँ पे जो वेजिटेशन है ये ब्लैक में दिख रहा है. कैसे व्हाइट ब्लैक में दिख रहा है? If you look at the linear patterns you have in your left bottom side of the screen, you will see linear patterns, something like a nadi. Irregular pattern में कुछ flow कर रहा है. तो जब नदी white पे दिख रहा है इसका मतलब vegetation black में होना चाहिए. ठीक है. So इस specific patch में जहां जहां black patches है, that is all vegetation. जहां जहां gray patches है, that is also vegetation, but some other category of vegetation, maybe grasses, maybe shrubs, but black indicates dense forest. Okay. So last slide mein forest was white, is specific mein forest is black. Yes, it looks like an X-ray. But it's not harmful. X-rays are harmful. Okay. So I'm repeating once again. Indices are ratios of wavelengths or bands. Bands which are being used are one with maximum information, one with minimum information. ठीक है? अब आप लोग ये पूछ सकते हो कि सर NIR माइनस R का मतलब क्या होता है? NIR में हम लोग क्या वैल्यू डालेंगे या R में क्या वैल्यू डालेंगे? So what are these values? Now, very simply speaking, suppose you have an image, and if you start expanding it or zooming it to a maximum level, so when you zoom it, you will see pixels, right? So pixels are appearing in that specific image. So when pixels are appearing, so every pixel has a value, जो हम लोग बोलते हैं pixel value या digital numbers, ठीक है? उसको DN values भी बोलते हैं या pixel values भी बोलते हैं. Now, these pixel values are then converted to reflectance values. This is all happening in the background in the software. Okay? These pixel values are converted using arithmetic equations into reflectance values. Now, what you see in this black and white image is an output of those reflectance values. Okay? So basically, we are giving an input. Input क्या होता है? Suppose we talked about radiometric resolution. Radiometric resolution, for example, 2 to the power 7 or 7-bit image. So 7-bit image मतलब 2 into 2 into 2 into 2 into 2 7 times. That becomes 128. So 128 different signals हैं. Now out of those 128, vegetation का कुछ एक value होगा. वेजिटेशन का जनरली हायर साइड में रेंज रहता है. यू कैन अज्यूम कि 100 के ऊपर का जो नंबर्स होगा वो वेजिटेशन का रहता है. वाटर बॉडीज का 11 के नीचे रहेगा, 15 या 11 के नीचे. सो हर एक पिक्सल जो निकलता है, हर एक पिक्सल का एक वैल्यू आता है. दैट्स कॉल्ड अ पिक्सल वैल्यू और अ डिजिटल नंबर. Now these values are mathematically recalculated as reflectance values in the as background work. You also have some manuals. So these manuals are available with each satellite sensor specifications and how to process them. So manually calculate करने के लिए. But if something is easily given to you, you don't have to actually work on it. When we will get the feedback page to fill after the session, you want to run away now. ठीक है? So you understand now? If it is a 7-bit image, 7-bit मतलब उसका जो range होगा वो 0 से 128 रहेगा. कैसे? 2 into 2 into 2 into 2 into 2 7 times. So that's the whole range of 2 to the power 7-bit image. Fine. Now उन range में जो brighter side रहेगा, that will be a part of your healthy vegetation. जो lower side रहेगा वो water bodies and non-vegetative रहेगा. So these digital number or pixel values are recalculated using some mathematical formulas into the reflectance values. And these reflectance values का ratio आप दिख रहा है आपको इस specific file में, जिसका range -1 से +1 में होता है. Okay, but as of now I will not be dealing much because that will become too mathematical for you and at times you will get confused. And my intention is to drive your attention and you become more attentive towards my lectures. ये remote sensing का attraction तुम्हारे तरफ है, ना कि you become offended कि अरे बाप रे कैसे होगा. ठीक है? So this is something which you can do. What are those black spots in the image? Black spots are forest. No, it's a forest. If that's what I was telling, the white lines indicate water bodies. Some patches you can also see clouds. ऊपर में देखोगे clouds भी दिख रहा है. Fine. No one has to be sorry for giving correct, wrong answer or any specific comments. Okay, it's I think it's better to interact rather than being silent. Don't worry. Okay, so I go to the next point now. Over here, and now we are starting with NDWI. NDWI is normalized differential water index. Normalized differential water index. Same concept like vegetation index, maximum by minimum. Okay. अब इसमें देखो एक फॉर्मूला है NDWI का, NIR minus SWIR divided by NIR plus SWIR. मतलब this specific equation will give you the water content information of leaves. दो formulas है ये slides में. If you see the second point and if you see the fifth point. So if your work or research interest is focused upon surface water bodies, then you have to use the fifth equation, fifth point equation. And if you're working on the leaf water content, then you have to use the second equation. Same concept, no problem at all. Highest information of leaf water content is obtained in NIR. Why? Because NIR again is very, very good for vegetation. Minus short wave infrared, SWIR, short wave infrared. So maximum NIR minus short wave infrared. Same content, same concepts. So I'm not repeating it again and again. Okay. Again, maximum information minus smallest information. और अगर surface water calculate करना है तो उसके लिए भी you use the next equation, which is green minus NIR by green plus NIR. मतलब surface water bodies का जो information है वो maximum आता है green band में और minimum आता है NIR band में. क्यों? NIR band में तो automatically vegetation ज़्यादा आ रहा है. तो vegetation जब उसमें ज़्यादा आ रहा है तो उसमें surface water bodies का information कम आता है. So it's a ratio of green minus NIR. Okay, so I'm repeating again. NDWI is an index which can estimate leaf water content and surface water body studies. But for the leaf water content, we have to use the equation NIR minus SWIR. NIR, I repeat again, near infrared. SWIR, short wave infrared. And similarly, for surface water bodies, it is green minus NIR, green minus NIR. And the respective values are provided over there. This is an output file. Now you might be surprised कि sir हम लोगों ने तो अभी black and white image देखा था, ये colored कैसे हो गया? Right? So this is the fun of GIS. You get a black and white image and then you can start playing with the colors. You have editing tools, you have symbologies, you can change colors, you can change contents, you can add features, you can describe information, you can add legends. So everything can be done in a GIS platform. And I have just given you one link again over here, which you can use for your further studies. And I really expect कि अगर आप लोगों को ये अच्छा लग रहा है तो आप इन YouTubes को देखो, एक दो बार देखोगे तो you will have more interest, तो तुम लोगों को और अच्छा लगेगा कि और हम क्या कर सकते हैं. So it's a very good platform to increase your research, future admission chances. You can think many things. There are many things over here. Okay. So how to use your basic education. Suppose you're a graduate in botany with some research experience in remote sensing. So you can go for phenology studies, कब deforestation हो रहा है, कब flowering patterns आ रहा है. Everything can be done in remote sensing and GIS. Okay. So all the way from black and white to colored, these are all possible using in GIS platforms. For urban planners, geographers who are interested to identify built up area, how built up area is expanding, changing. So to identify those features, we are having this specific equation, which is SWIR minus NIR. That is short wave infrared minus near infrared. So on the other hand, you can also recall, if you just reverse the question pattern, if I ask what is which band is used for getting the maximum information of vegetation, so you can say near infrared. Which band is used for minimum information of built up area, so it will be again near infrared. Okay, so minimum information and maximum information. कौन से बैंड में सबसे ज्यादा built up information मिलेगा, वो है short wave infrared. ठीक है, so try to understand कि एक ही चीज में how you can get confused. NIR band is suitable for option 1, vegetation studies. Yes, it's also true. Option 2, built up studies. Yes, even that is true. Okay, so don't get confused. NIR band is useful for both the cases. NIR band is also used for vegetation studies because we are also using it in the equation for water index. So one specific band, but useful in multiple ways. Okay. So my basic intention was to give you an exposure of what indices are, and just three basic indices I have dealt with over here. Now the concept of these indices will stay constant. अब आप इसमें कोई भी इंडाइसेस ले लो, सबका कॉन्सेप्ट सेम रहेगा, बैंड्स वैरी करेगा, ठीक है, जैसे बैंड वैरी करेगा यू कैन अंडरस्टैंड बेस्ड ऑन द फॉर्मूला कि जो फर्स्ट वैल्यू रहेगा बैंड का दैट इज योर हाईएस्ट, जो माइनस में रहेगा आफ्टर माइनस दैट विल बी योर मिनिमम, ठीक है. सो इन इंटायर रेशियो कॉन्सेप्ट maximum information minus minimum information divided by maximum information plus minimum information. Always remember these things. So NDVI we are using for urban sporal assessment, urban density assessment, expansion projects. So these are all being done over there. Fine. This is just I took again from website, one source of research paper, and they were dealing with how urbanization is occurring. So ये उनका था. And you can color the, you can change the colors. ये color fix नहीं है, ये उस specific scientist ने डाला अपना specific color. You can change the colors. So let us see if we can do something. We have, I think, another 6 minutes. So maybe I can recap once again, and you can do it as a homework, just for learning something extra if you want to. If you're not too exhausted after the 2 sessions. First is whenever we talk about wavelengths or spectral bands are individual wavelengths. For example, red wavelength is one spectral band. Green wavelength is one spectral band. The wavelength of each, for example, red is something around 0.6 to 0.7. NIR ka 0.7 say 1.3. Green is 0.5 to 0.6. So these are all spectral bands. Indices is a ratio of bands. So we are using 2 bands to derive a ratio. The output of these ratios will always be between -1 to +1. Higher range always recommends the better vegetation patterns or denser urbanization. Lower values indicate just the opposite. Same concept is being used for NDWI and NDVI. Okay. NDVI stands for Normalized Differential Built Up Index. Okay. NDVI, Normalized Differential Built Up Index. NDWI, Normalized Differential Water Index. NDVI, Normalized Differential Vegetation Index. Okay. So with this, I end my session. If there are any queries, you can ask me. We have 4 minutes left with us. More or less, I have tried to explain and elaborate upon what the indices are. Even I tried to recapture what was taught in the last lecture and even in yesterday's lecture. So you have to link everything together, and you have the links, YouTube links with you. So if you read more, you will be able to understand the concepts. And I don't see questions popping up. So what is an FCC? Okay. FCC stands for false color composite. What do you mean by an FCC? FCC is not the real replication of world. When the features are not shown in the real color scenario, then that's called a false color composite. मतलब अगर वेजिटेशन हरा दिख रहा है तो वो ट्रू कलर कॉम्पोजिट है, मतलब कोई चीज अगर अपने ओरिजिनल कलर में दिख रहा है, दैट्स कॉल्ड ट्रू कलर कॉम्पोजिट. And whenever you have a different color to it, that becomes a false color composite. How do we calculate the number of bands to get the spectral bands? Very simple. थोड़ा सा ध्यान दोगे दीक्षा, you will understand. Like if I told you list 3 linear imaging self scanner is the is a sensor. Now this sensor has 4 spectral bands. 4 spectral bands बोले तो it has red band, it has green band, it has blue band, and it has an NIR band. So we are having 4 bands in list 3: R, G, B, NIR. Okay, so this is 4. So when we say how many, what is the spectral resolution? We say 4. Okay, and then we describe these 4. What are these 4? What will be the FCC image of an agricultural land? Agricultural land will be your light pink, light orange. That will be agricultural land. Sir, please elaborate upon SAVI. This is soil adjusted vegetation indices. In this SAVI, you also have soil component added to it. It's also a vegetation indices, but you also have the soil component in it. So uske basis pe ratio calculate kiya jata hai. What is the difference between SIR and R? Are you telling to NIR or R? I hope, Sam, what I understand, it should be NIR and R. NIR is near infrared band, which is invisible band. R is a red band, which is a visible band. R band is used as a primary color for formation of colors. So R is the visible band. You can see red color in optical remote sensing. NIR is colorless band. You cannot see it. इंफ्रारेड में इंफॉर्मेशन ज्यादा क्यों मिलता है? इंफ्रारेड में इंफॉर्मेशन ज्यादा इसलिए मिलता है क्योंकि वो वेजिटेशन पैटर्न के मेसोफिल टिश्यू से रिलेटेड है. ओके, द इंफॉर्मेशन इज बेस्ड अपॉन द मेसोफिलिक टिश्यू, thus the more information. Okay, thus you have more number of information when you're dealing with an NIR band. I think there's a repetition of question, Diksha. I already explained that. How do you calculate the number of bands? आप number of bands कैसे estimate करते हो? Again, the same process. Red band, green band, blue band, NIR band. 4 band है, तो we say it's a 4 spectral band. So I think as of now, no questions are being popped up. Even if the session is over, you're free to question me tomorrow. No issues, okay? If there are certain things which comes in your mind after the session is over, maybe if you read some things, again, I'm seeing NDVI stands for Normalized Differential Built-Up Index. Built-up. Normalized Differential Built-Up Index. Dr. Chakravarti, your voice is mute. Your speaker is off.
Thank you, sir. That was an intense session. A question from my side, sir.
Yes.
Can I?
Yes, sure, please.
What is the difference of panchromatic and multispectral sensors? Like, what is the difference? It's too heavy a thing.
Yeah. Panchromatic is basically, in short form, we call it as a pan sensor, PAN, panchromatic, but it's a single band sensor.
Okay.
Now, being a single band sensor, it is black and white in color.
Mhm.
And colors are always more informative compared to a black and white image. But a panchromatic image has a plus advantage that the resolution is very high of 5.8 meters. Okay, so at 5.8 meters, the spatial resolution is too good. So you are able to distinguish features at that specific resolution. But multispectral is 3 bands colored. That's the benefit.
So in accuracy, from that point of view, which is better if you rank them?
For my personal use, if you say as an environmentalist, I will work on a multispectral image. But if you merge, there are options of merging panchromatic with MSS images. So that will give you a much better information because high resolution and high color information both can be merged together.
So if I'm not wrong, the slide that in which you were showing the Landsat and the
Yes.
NDVI, one was panchromatic and the other was
One was
multispectral.
multispectral.
So I think the participants would also love to know that. So you have shown very beautifully the difference and the images, how, you know, the two kinds of sensors would project. These two sessions, you have carried us through the nitty-gritties and the key concepts of GIS and RS, which I think most of the participants have benefited as much as we have as teachers too. Thank you so much for putting all the concepts, the complex concepts, into such an easygoing and, you know, graspable mode. It is very interesting to learn that with the help of RS techniques, we can gather information about the surface of Earth from a different platform, as Sir has said, like a satellite or an airborne sensor, and spectral properties of vegetation in different parts of spectrum can be interpreted to reveal information about the health and status of crops, rangelands, forests, and other types of vegetation through NDVI and others. Thank you once again, sir, for this volume of knowledge that you have given to us and for enriching us.
Thank you so much.
Extending my special thanks to our patron and principal, Dr. Sister Jyoti, for her continual support and guidance. Thank you for gracing this session, Sister. It means a lot to all of us. It is your guidance that has really shaped this program and made it a big success. My heartfelt gratitude to the CP coordinator, Dr. Devjani Roy, for her continuous support, mentoring, and guidance. Thank you, ma'am, for being there for us. I thank each and every member of the organizing team without whom this day would not have been a success. An appreciation for all the participants for being patient, composed, and interested, and very active throughout the session. All of you have really made these two sessions and the entire day a big success. Thank you, one and all. There is a small announcement for the participants, requesting all the participants to submit the quiz and feedback forms that have been posted to you on YouTube and your WhatsApp group. The link is there and will be there for 1 hour more. I remind you that it is mandatory for you to fill up these forms and submit it in time. The YouTube link for tomorrow's session will be sent to you soon. We start tomorrow at 11 a.m., the session 5 on day 3 with fundamentals of GIS. As we come to the end of the session, I seek the permission and the blessings to conclude the day from our patron.
Okay, please go ahead.
Thank you, sister. Thank you for providing us this platform and for bringing so much of knowledge sharing. Thank you. Bidding adieu to all, stay safe, stay motivated, and let's meet afresh tomorrow at 11 a.m. for our session 5, Fundamentals of GIS, and that will be at 11 a.m. Thank you once again.